Today we're going to discuss the differences between theoretical and experimental probability. First, let's consider the probabilities associated with rolling a normal six-sided die. Well, the outcomes of rolling this die just once are a 1, a 2, a 3, a 4, a 5 or a 6. And each of these outcomes we are going to assume to be equally likely to occur. When we talk about theoretical probability, we're talking about calculating the chance of outcomes occurring before any event has taken place. So what this means here is we are calculating the chance of each outcome here occurring before we roll the die. Let's start with the outcome of a 1 being rolled. We can describe this probability as being a 1 in 6 chance, represented here as a fraction, which can then in turn be converted to a decimal, which is approximately 0.167. Because we are assuming that each of these outcomes here are equally likely to occur, we can hence say that each of these outcomes has an approximate chance of 0.167 of occurring. So to summarise, theoretical probability is the calculated chance of an outcome occurring before any event or trial has taken place. So how does this differ from experimental probability? Well, let's continue with our rolling the die scenario. What if I were to roll this six-sided die 30 times and record the result each time? What I can then do is use this information to calculate the probability of each outcome occurring based on the 30 rolls. To do that, I first tally up how many of each outcome occurred in my 30 trials, and I can record it in a table like the one I've got here. Then, to calculate the probability based on the experimental data, those 30 trials, I divide the number of times the outcome met our success criteria by the total number of outcomes of our trials. For example, to calculate the experimental probability that this die will land on a 1 based on our results, I take the number of times a 1 was rolled, which is 9 times here, and divide that by the total number of trials, which is 30. This gives me an experimental probability of rolling a 1 that is equal to 0.3 based on our previous results. I can then repeat this for each one of the outcomes to calculate the probability of each of these occurring based on my 30 trials. But right now you might be thinking to yourself, how can the experimental probabilities be so different from the theoretical probabilities and even from each other if the chance of each outcome is supposed to be equal? Well, there are numerous answers to that question. The first of which is we have assumed that each outcome has an equal chance of occurring, which it may or may not. But what we can use experimental probability to help determine is whether this is true, if experimental probability is used and understood correctly. There is one main important factor that I want you to consider that has a significant impact on experimental probability, and that is the number of trials that you are calculating the probabilities from. The more trials that you perform and base the calculations from, the closer the experimental probabilities are likely to be to that of the true probabilities. Let's, for instance, take our example of rolling the die. When I based my calculations from 30 trials, there was a significant difference in the experimental probabilities that were calculated, which suggested that each outcome was not equally likely to occur. If you look at the difference in our experimental probabilities of rolling a 1 compared to a 5, there is a significant difference in this occurring based on our trials. But that doesn't mean that these two outcomes aren't equally likely to occur. What if I were to roll the die more than 30 times? What if I were to roll the die, say, 200 times? How would this affect the probabilities I calculate? Well, With the power of editing, I have just done this for us, and I've tallied up the total number of times each outcome occurred and hence found the experimental probabilities for each based on my 200 trials. So, what do you notice about these results? Did they vary from each other as much as they did with only 30 outcomes? Equally, were they all the same, like we were expecting from our theoretical predictions? What you should notice is the outcomes no longer vary as much as they did with the fewer outcomes. But they also don't necessarily balance out perfectly to the theoretical probabilities. What does occur though is the more trials you do, the closer the experimental probabilities will end up being to the true probabilities of each outcome occurring. So, to recap, theoretical probabilities are the calculated probability of outcomes occurring before any trial has taken place, whereas experimental probabilities are calculated probabilities on outcomes that have occurred on a series of trials that have taken place. The more trials that these are based on, the more likely this will be closer to the true probability of outcomes occurring.